Hi guys, um, welcome to Module 1, Lesson 1, Chapter 8, Algebraic Reason, Graphs, and Connection with Geometry by me, Miranda Curtis. Let's go. Okay, our first question is question 1A. Draw a graph for each of the following scenarios and explain why your graph corresponds to the scenario. Label axes and include scales. Okay. Our first scenario is show and explain a graph to correlate with the function of the amount of gas in a gas tank when a driver refills the tank on a drive across country. Okay, my little red car up here on the screen, he gets 25 miles to a gallon. So we're going to do distance on the left side, and we're going to do fuel in gallons on the right. So when he's sitting 0 miles, he just filled up his whole tank. He's got 10 gallons. Now, we need to figure out how much gallons of gas he has, so many miles. So for his car to be full, the miles, you times 10 times 25 gives you 250 miles on full. That is before he has to get gas or anything. So our next point, at 125 miles, how much gas does he have left that he has to refuel? So we got 5 gallons, which is half, because if you subtract 125 miles from 250, that is half. And so half of 10 is 5. And our little car's going down. So right here is our y-axis, and this is the fuel gallons. This is what we started at 10 gallons. And when we went to 125 miles right here, and we need to fill up, it tells us right here that we needed 5 gallons of gas. Okay, here's our next one. This is question 1B. Draw a graph for each of the following scenarios. Explain why your graph corresponds to the scenario and label the axes, include the scale. Okay, so our scenario is show and explain a graph that correlates with the function of the elevator. Stops at each level on the way up. The hotel has 10 floors, and there is a guest on each floor that needs to go to their room. So our little spots right here, it correlates to our spots, because we're going to stop at the first floor. 0 right here is our ground floor, so everybody's getting on. And so our little elevator is going to go up each step. It's going to stop at each step. Right here, we have 2, and it's going to stop, and then at level 3, all the way up to level 10. On level 10, it stops right there, because it said going up. It didn't say coming down. That's all that is. Okay, here's our next one. Okay. Here is, it says show an example of graph to correlate with the function of the height of a bouncing ball dropped from table. The height of the table is 18 inches. And so our graph right here, our y is the height of the table, which starts at 18. And our x-axis is the height of the bouncing ball. When the ball drops, it's going to hit, right? It's going to hit the ground first. That's why the ball bounced like that. It's going to hit the ground first and then come halfway up. And our next spot is where it measured on the table at 9, and then it bounced all the way to the ground again. And then it came up to the table again, and it hit 6, and then went all the way down. And then the ball lost its momentum and just started rolling. Okay, here's question 1D. Draw a graph for each of the following scenarios. Explain why your graph correlates to the scenario and label the axes and scales. Okay, so this one is show and explain a graph to correlate with the function of the length of a shadow of a flag pole, length of a shadow of a flag pole throughout a sunny day. The flag pole is, its coordinates are 6, 0, and the shadow of the flag pole is 3, -4. So we're going to have to do distance because it's a sunny day. We don't know which way the wind is. But our Pythagorean theorem is d square root of xz minus x1 squared plus yz minus y1 squared. And so we put in our coordinates, And so we come down here. Those are supposed to be triangles. So this is for distance right here. So we have 3 squared, which is that one right there, plus 4 squared, which is right there. We'll get to this 25, and our distance square is 25. So we have square root 25 is 5. So right here, here are our points. Here's 3, -4. Here's our point, 6, 0. This right here, 6 minus 3, we're taking our x's. The y-axis is right here, and then the x-axis is right there. So right here, 6 minus 3, we're taking x's. 6 minus 3 is 3. That gives us our red line. And then 0 minus -4 is 4. So here's our flag. This is right here. This is the shadow right here, which is a 5. That will we got in our distance formula. There goes our flag. It's flying. Okay, here's question 2, A through D. Suppose 2 function machines are hooked up in a sequence so that the output of machine G empties into the hopper of machine F. Such a coupling of machines, which is defined as the range of G, is substituted of the domain. My little screen, I have to move my little screen a little bit. Sorry. Okay, domain of F is called the composition of F and G and can be written Fx equals FGX. Suppose F is the triple function of XX equals 3x, and G is the add 8 function of Gx equals x plus 8. Suppose the tripling and the adding of 8 machines are coupled in reverse order to define the composition of G and F given by Gx equals Gfx. Then G4 equals Gf4 equals G3 times 4 equals G12 equals 12 plus 18 equals 20. So here's our first question. Show and explain Gfx for x equals 0, 1, 2, and 3. So the first one, we're going to look at 0. So we're going to fill it in. We're going to put Gf0 equals, and then we're going to fill it in as we go. So it's going to be G, 3 times 0 is 0. So then we're going to do the plus 8. So 0 plus 8 is 8. Okay, now we're going to fill in 1 for our x. Okay, so we're going to do the same thing. We're going to go Gf1, and then we'll move down to Gf. 3 times 1 is 3, and then 3 plus 8 is 11. Okay, then we're going to fill in our 2. Okay, Gf, and we put our 2 where our x is, and we put Gf. 3 times 2 is 6. 6 plus 8 is 14. And then remember, we're going to do our 3. Okay, so we got Gf3. And then we're going to fill it in. So we're going to go Gf. 3 times 3 is 9. We're going to go 9 plus 8 is 17. Okay, here's question 3a. Show and explain the slope of the line segment determined by the given pairs of points in each case. Tell whether the segment is vertical, is horizontal, slopes upward to the right, or slopes downwards to the right. Complete parts A through C below. Graph each and label axis and scale. Okay, so our first points are P31 and Q55. Okay, so we're going to come in here with a formula, which is x1 to y1 and then x2 to y2. And I made sure to label it for you right here. That way it's not as confusing when you put it down. So we're going to go M y2 minus y1 over x2 minus x1. So we're going to come up here to our formula, and we're going to put 5 minus 1 is 4, and then we're going to go 5 minus 3 is 2. And when you divide it, you get 2. So PQ slope is a 2, and when we put it on our map, we put it over here. So our y-axis is right here, and our x-axis is here. And so we'll come down here. We just moved it over here. So 5 minus 3 is 2. We have our red line. And then right here, we're taking 5 minus 1 is 4, and it's going to make our black line. Okay. And then here is 3b. Again, we're going to show and explain the slope of the line segment determined by the given pairs of points in each case, then whether the segment is vertical, is horizontal, sloped upwards to the right, or sloped downwards to the right. Okay. Now, our points are R is 5, 8, and S is 5, -8. Again, I put this right here for you, so it makes it easier to know which one's x1, y1, x2, y2. So we're going to put it in our formula right here, y2 minus y1 over x2 minus x1. So -8 minus 8 is a -16, and 5 minus 5 is 0. So when we come over here and we graph it, it's a straight line down, which is, it's an undefined, it's vertical, because 0 over -16 is in our slope. It doesn't give us a slope, it's undefined. So we have right here, here's 1 point, right here is 5a, it's -8 minus 8 is 16, and down here is 5 -8, and it's 5 minus 5 is 0. Okay, here is C3. Show and explain the slope of the line segment determined by the given points and tell where the segment is vertical, horizontal, slope to the right, slope downwards to the right. Okay, so we have, here's our new point. Here's C. U is a -1, -4. V is a -4, -13. Okay, here is our graph. We have the y-axis right here and the x-axis. Okay, again, I made sure for the x1 and the y1 so it wouldn't be confusing. Okay, right here we have our y2, which is -4, and our y1 is minus -13. And down here is x2 minus x1, which is -1 minus -4. Okay, -1 minus -4 is 3. That's our red line. -4 minus -13 is 9. So if you look at our line, it's upwards to the right. Our slope is 9/3. Our slope 9/3, and you divide, slope gives you 3. That's our line segment. Okay, here's question 4, A through C. Show and explain the graph of following functions and describe the similarities and differences between the graphs. Okay, here's y equals x squared. What we're going to do is we're going to put it in, I have it in a little thing right here. We have y right here, -2, -1, 0, 1, and 2. What we're going to do is fill these in. So -2x squared is 4, -1 squared is 1, 0 squared is 1, 1 squared is 1, 2 squared is 4. Okay, and this is our graph right here. And you see these are points, -2, 4. Then you have -1, and this makes this little W. Okay, B is y equals x squared plus 4. Again, we're going to do the same thing with over here. -2 all the way to 2. We're going to fill it in. -2 squared plus 7 is 3. -1 squared plus 7 is 6. 0 squared plus 7 is 7. 1 squared plus 7 is 8. 2 squared plus 7 is 11. And we're going to come over here, we're going to graph those points. And it's going to give us this cool little line. It's not as W as this one, but it is similar. And it's just a little bit loose right here. Okay. We're going to go and see, notice that graph of y equals x squared plus 7 is the graph of y equals x squared, shifted 7 unit points up. That's why our W is not a W. It's just going that way. Okay, here's C. Y equals x squared minus 7. Again, we're going to do it in the form x right here, -2, -1, 0, 1, and 2. We fill it in like we did the last two. Okay, -2 squared minus 7 is -11. -1 squared minus 7 is -8. 0 squared minus 7 is -7. 1 squared minus 7 is -6. 2 squared minus 7 is -3. So we're going to graph those points too. You notice these two are similar. They are, but this one is different. You notice how it's going down more. Okay, notice that the graph of y(x squared minus 7 is the graph of y equals x squared shifts down 7 points. So this one was shifting up a little bit right here. Now this one's coming down. Okay, the relationship between the graphs, they are vertical shifts of the same curve. If you put these all together, you'll notice these little points right here will come in right below here. Okay, here's question 5, A through B. Okay, show and explain the equation of the line through the given points that are perpendicular to the given slope of the perpendicular line and negative receptacle of slope given if the line is neither vertical nor horizontal. Okay, so these are fun. Two non-vertical lines are perpendicular if their slopes are negative receptacles of each other. Any vertical line is perpendicular to any horizontal line, which case should be used to find the slope of the perpendicular line. See, the case when the lines are not vertical, you have to use this formula. Use y equals mx plus b. M, we're going to flip -3/4, and it's going to be -4/3. Then we're going to come down here, and we're going to put these in here. We're going to use what is the slope of the line perpendicular to that. So what we're going to do is we're going to do y equals -4/3 x plus 5, and we're going to flip it again. It's going to be a +3/4. So now we have to find the point slope of the equation of a line, which is y minus y1 equal m inside parentheses x minus x1. So then we're going to fill in our 6 and our 1. So y minus 1, -1 equals 3/4, and then x minus 6. Oh, I forgot the x right there. Supposed to be x right there. Okay, then we're going to come down here, and what that's going to give us is y plus 1 equals 3/4 x minus 8, because we brought this over. And then what we're going to do to try to get y by itself, we're going to do +1 minus 1 here, and we're going to do it down here, which is going to give us 9. So our answer is y equals 3/4 over x minus 9. Okay, now we have b, which is 2y plus 9x minus 5 equals 0. And then our points are 0 and 3. Okay, with this one, we're going to have to use the point formula again, but we're also going to use y equals mx plus b. But we're going to try to get the y by itself. So we're going to do 2y over here, which is going to cancel out. We're going to bring 2 over here, and which is going to give us y equals -9 over 2 x plus 5, 2. Okay, which is m is going to be 2 9s. And then we're going to do our point slope again, which is y minus y1 equals m x minus x1. So then we're going to fill it in. Y minus 3, we're going to use our points over here again. Y minus 3 equals 2 9s over x0. Okay, and then our answer is y equals 2x9 plus 3. Okay, and then here's C. I love the last one. 6 is awesome. This one's fun. Okay, show and explain the equation of the line that is tangent to the circle and radius of 9 at 0 and 9, and whose center is at the origin. Okay, so we're going to use this formula. Y minus d is a minus c over d minus b and xc. We're going to fill it in. So we're going to use our 9s and our 0s. So y minus a -9 equals 0 minus 0 over 0 minus -9 and x minus 0. So y minus -9 is 0, and our answer is y equals -9. It's because our origin of our circle is 0, 0. Okay, so B, show and explain the equation of the line that is tangent to the circle of radius of 9 at 0, 9, and whose center is at the origin. Again, the origin of the center is 0, 0. So we're going to use, again, our formula, which is y minus d equals a minus c over d minus b, x minus c. So we're going to fill in, again, right here, we're going to fill it in. Y minus 9 equals 0 minus 9 over 0 minus 9. Or 0 minus 0 over 0 minus 9. Sorry, guys, I'm tongue-tied. X minus 0. So we're going to fill in y minus 9 equals 0, y equals 9. So don't forget the origin was 0 of 0. So we're going to get positive 9 this time. Last time we got -9. So it says compare the line in part B to the line in part A. Recall that the line A is y equals a -9, and line in part B, excuse me, is y equals 9. Remember that that two lines are parallel if their slopes are equal, and two lines are perpendicular if their slopes are negative receptacles of each. other or are horizontal and vertical lines. Notice that both lines have the same slope, and they do. One's negative, one's positive, and therefore the lines are parallel. Thank you guys for hanging in there for chapter 8. And I cannot wait to see you guys for another lesson. I hope you guys got a lot out of this. If you liked it, that's awesome. If you didn't like it, just leave me a comment and tell me what I could do better. Okay, thank y'all. Have a good one.